Welcome to qnawire.
In this question, we have this setup whereby the crank AB is rotating with a constant angular velocity of 4 radians per second. We need to determine the angular velocity of the rod CD at the instant theta equals to 30 degrees. So based on this geometry, based on this setup, we can draw a triangle for ABAC. So this is how the triangle looks like. C, A, B. So this is 0.6 meters. Then we call this theta. This is phi. And then this is 0.3 meters. And then, so this vertical length will just be 0.6 minus 0.3 cosine phi. Okay, so this is 0.3 cosine phi. So this remaining distance will just be the difference. Okay, so to start, we'll be writing down the position coordinate equation for points B. Okay, so from point A, x is equal to 0.3 sine phi. Okay, just so this is 0.3 sine phi, and then from C, we have x equals to 0.6 minus 0.3 cosine phi tangent theta. Okay, the purpose is to get an equation with theta. So this is how we get one equation with theta. Okay, and also we need to utilize the given information, which is this omega AB, which is equal to phi dot. So that's the reason why we need to write these two equations. Okay, so the two x coordinates are the same, so we can write down 0.3 sine phi is equal to 0.6 minus 0.3 cosine phi tangent theta. Okay, simplify, you get sine phi is equal to 2 minus cosine phi tangent theta. Okay, then we will be taking time derivative. This time we only need to do it once. Okay, so we have cosine phi dot is equal to so differentiate this thing will be so using product rule. The first term will be we get sine phi tangent theta phi dot, and then when we do the second term, we get 2 minus cosine phi secant squared theta dot. Okay, so theta dot is going to be phi dot cosine phi minus sine phi tangent theta divided by 2 minus cosine phi secant square theta. Okay, so then the next thing is to find what is the value of phi when theta equals to 30 degrees. So when theta equals to 30 degrees, we have sine phi. Okay, we substitute this into this equation. Theta equals 30 degrees into here. So we have tangent 30 degrees. Okay, so there are a few ways to go about doing this. So tangent 30 degrees is square root 3 over 3 or 1 over root 3. So you have root 3 sine phi equals to 2 minus cosine phi. Okay, you can try to get rid of the square root 3 by squaring both sides. So you have 3 sine square phi is equal to 4 minus 4 cosine phi plus cosine square phi. Okay, then you have 3 minus 3 cosine square phi. So this is, I'm using sine square phi equals to 1 minus cosine square phi is equal to 4 minus 4 cosine phi plus cosine square phi. And here you get a new equation saying that 4 cosine square phi minus 4 cosine phi plus 1 equals to 0. So you have 2 cosine phi minus 1 square equals to 0, which means that cosine phi equals to half, phi equals to 60 degrees. Okay, so going back to the theta dot equation, so when theta equals to 30 degrees, phi equals to 60 degrees, and we know that phi dot is equal to 4, then putting in the numbers, so theta dot equals to 4 times cosine 60 degrees minus sine 60 degrees tangent 30 degrees divided by 2 minus cosine 60 degrees secant square 30 degrees. And then if you calculate, you get 0. Okay, so the numerator is just going to get 0. Okay, so this is the answer for this question. Okay, so theta dot at that instant, if you go back to the diagram, if this is 30 degrees, this is 60 degrees, you have a right angle triangle. So so when AB is moving, swinging clockwise, when at this particular angle where you have a right angle triangle, the rod CD is not going to move at that instant. So that's why theta dot is 0. Okay, that's how we can make sense of this situation.